one of our closest neighbors in the universe, which is why there has been a lot of attention paid to it. However, the recent discovery of a miles-long structure has had scientists disagreeing with each other as they try to explain the origin and nature of the object. What is this object? Does it pose a threat to the moon or us? Let's find out as we dive deep into the details of this huge miles-long structure detected moving above our planet close to the moon. The moon is more important to us than many people realize. This object, the brightest and largest object in our night sky, makes Earth more livable by moderating our planet's wobble on its axis, resulting in a relatively stable climate. It also causes tides which have guided humans for thousands of years. The moon is less than 1/3 the width of Earth, with a radius of about 1,018 miles or 1,740 kilometers. The moon would be roughly the size of a coffee bean if Earth were the size of a nickel. The moon is 238,855 miles or 384,400 kilometers away on average. That means between Earth and the moon, 30 Earth-sized planets could fit. The moon is gradually receding from Earth, but don't worry, we still have it with us for a long time yet, as it's moving an inch further away each year. With no atmosphere to deflect impacts, a steady rain of asteroids, meteoroids, and comets strike the moon's surface, leaving numerous craters behind. Over billions of years, these impacts ground up the moon's surface into fragments ranging from massive boulders to powder. The lunar regolith, an astronaut's nightmare because of its destructive properties, is a rubble pile of charcoal gray, powdery dust and rocky debris that covers nearly the entire moon. And beneath this is the megaregolith, a region of fractured bedrock beneath the surface. Because the moon rotates at the same rate as it revolves around Earth, a process known as synchronous rotation, the same hemisphere always faces Earth. Some people refer to the far side, the hemisphere we never see from Earth, as the dark side, but this could be misleading. Different parts of the moon are in sunlight or darkness at different times as it orbits Earth. The changing illumination is what causes the moon to go through phases from our perspective. During a full moon, the sun fully illuminates the hemisphere of the moon visible from Earth. A new moon occurs when the far side of the moon is in full sunlight, while the side facing us is in darkness. The moon orbits Earth in 27 Earth days and rotates or spins at the same rate or in the same amount of time. Because the Earth is also moving, that is, rotating on its axis as it orbits the Sun, the moon appears to orbit us every 29 days from our perspective. Thanks to its proximity to the Earth, the moon is a favorite object for study for both amateur and professional astronomers. It is little surprise then that the moon has often produced shocking discoveries that confound observers. Take, for example, something massive that scientists just discovered lurking underneath the far side of the moon. This mysterious blob has the mass of a metal pile 5 times the size of Hawaii's Big Island. The structure is located at least 180 miles beneath the South Pole Aitken Basin, a massive crater punched into the lunar landscape billions of years ago when the moon's initially molten surface had cooled enough for impacts to leave a lasting mark. The anomalous blob was discovered by combining data from NASA's Gravity Recovery and Interior Laboratory or GRAIL mission with topography from the Lunar Reconnaissance Orbiter. This information assisted them in refining previous calculations for the thickness of the crater's crust and the density of the mantle, revealing the unusual underground surplus of mass. Scientists say the blob is likely related to the formation of the crater and maybe the remnants of an ancient impactor's metal core. While the extra mass isn't immediately visible from the surface, it appears to be having an impact, dragging down the lunar landscape in a strange ovoid depression that sits more than half a mile lower than the surrounding crater floor, known as the Central Depression. The South Pole Aitken crater, where this mysterious object was discovered, has previously piqued the interest of scientists due to its surface composition and size. It is the largest preserved crater in the solar system that we know of. However, the discovery of this strange mass only adds to the mystery, especially since the crater and the nearby lunar South Pole are potential targets for a number of future moon missions. Scientists are eager to investigate the mass because such an effort could aid in unraveling the history of the massive impact that formed the crater. as well as filling in critical details in our understanding of how our lunar companion and other celestial bodies grow over time. Ebb and Flow, the Grail mission's twin spacecraft, launched in 2011 and orbited the Moon for nearly a year, precisely charting variations in the lunar gravitational field. The Grail team used this data to create the highest resolution gravity map of our lunar companion to date. The data provides a hazy picture of what's going on both above and below ground. The greater the mass, such as higher topography or denser rocks, the greater the gravity. These maps show a clear distinction between most of the Moon's large craters and the South Pole Aitken Basin. Other large craters have mascons, which stand for mass concentrations. Mascons, discovered by scientists at NASA's Jet Propulsion Laboratory in 1968, appear as bullseyes on gravity maps, a central circle of strong gravity surrounded by a ring of weak gravity and then another ring of stronger gravity. The effect is caused by the way the low-density crust and high-density mantle adjust after an impact. However, there is no such pattern in the South Pole Aitken Basin. To figure out what was going on beneath the surface, the scientists turned to calculations, developing a model that more accurately reflected the natural system by making new assumptions about the forces at work. The findings revealed a large zone of dense material within the Moon's upper mantle. Scientists propose two explanations for the subsurface mass. For starters, it could be remnants of dense oxides formed during the final stages of cooling when the Moon was covered in ancient magma oceans. However, the researchers lack a mechanism to precisely explain the formation of such a layer under the basin because the question remains, why of all places would it be there? However, the mass could have been caused by an ancient impactor. The space rock that formed the Moon's giant basin was likely large enough to have separated into different layers when it first formed, so it had a dense, metallic core and rocky outer layers like many of today's planets. The energy of the impact carved a deep bowl-shaped crater on the Moon on the fateful day of its collision, with the impactor's metallic core smashed up inside. The original hole, however, did not last, and the divot on the Moon was partially filled with molten rock. The melted traces of the ancient impactor's core lingered within it. In addition to discovering the mysterious blob, the new study retraced the inner rim of the basin, revealing that scientists had previously underestimated the crater's size, a potentially significant discovery as NASA and others prepare to send missions to the basin and the nearby lunar South Pole. The most recent researchers to map these boundaries used data from the Clementine mission, which had a gap near the basin's southern end. The most recent study, on the other hand, used more complete data from the LRO and Grail, revealing that the crater is roughly 40 miles larger than previously thought. Overall, the work adds to the already heightened interest in the South Pole Aitken Basin. Scientists hope that by better understanding this structure, they will be able to better understand the formation of bodies throughout our celestial family. Every planet in our solar system was formed by small things colliding and eventually forming larger things. The constant churn of plate tectonics on Earth has been steadily erasing the planet's ancient surface and record of early impacts. However, the Moon, which still has a billion-year-old surface, serves as an incredible record of what happened when our solar system was a baby, including the dramatic events that formed one of the largest known impact basins in our cosmic neighborhood. The discovery has also brought more attention to the so-called dark side of the Moon. The Moon wasn't born this way. Astronomers believe it began its life spinning at a very different rate than most natural satellites. In the case of our Moon, astronomers believe it once spun faster on its axis. However, gravity from our planet exerted torque on bulges on the lunar surface over time, forcing its rotation to align with its orbital period. This is a common occurrence. Many of Saturn's and Jupiter's moons are tidally locked with their parent planet. The Luna 3 spacecraft was a spacecraft launched from Kazakhstan's Baikonur Cosmodrome in 1959. Luna 3 was the third spacecraft to reach the Moon and the first to return images on its far side. The images were noisy and indistinct, but because the Moon always presents the same face to the Earth, the grainy photographs sparked excitement because they gave us the first views of a previously unseen part of the Moon. The far side of the Moon is a surprisingly different experience. The most noticeable difference in the Luna 3 images is the absence of the large dark seas of cooled lava known as maria, which cover a significant portion of the Moon's near side. Instead, the far side is densely packed with impact craters of various sizes and ages. 50 years later, in 2009, the Lunar Reconnaissance Orbiter, or LRO, launched from Florida's Kennedy Space Center. Scientists can now accurately recreate the view captured in the pictures from Luna 3 using LRO's global elevation maps and photographic mosaics, both of which are of unprecedented quality and detail. Luna 3 was 61,700 kilometers above the surface, directly over 12 degrees north, 120 degrees east, with its camera banked 17.5 degrees clockwise from vertical relative to the Moon's north pole. The line at 90 degrees east along the left side of the LRO image delineates the boundary between the Moon's near and far sides. To the left of that line is the well-known Maria Crisium, the circular spot near 9 o'clock, Marginis Smithy both east of Crisium, Humboldt Tiayanum at the north, Australa near the south pole, and the eastern edge of Fecunditatis. A cluster of unnamed craters near the disk's center is surrounded by King, Langemak, Gregory, and Abul Wafa craters. Because it is near the subsolar point, the brightness is enhanced. Tsiolkovsky crater and its central peak are visible in the southern hemisphere as a dark, sharp-edged shield shape with a white dot in the center. The crater Jules Verne is located to the southeast of Tsiolkovsky, and Moscoviense is the mare in the northeast. However, it would be China to take the glory for landing the first mission on the dark side of the Moon. China's expanding space program announced plans for a historic landing on the far side of the Moon in 2016. Since 2003, when China launched its first astronaut, the multi-billion-dollar space program run by the Chinese military has been on track to meet the milestones it set for itself. The unmanned spacecraft Chang'e 3 made a soft landing on the lunar surface in late 2013, making China the third country after the United States and the former Soviet Union to reach the Moon. The rover Yutu, or Jade Rabbit, which was launched from Chang'e 3 after landing, discovered a new type of basaltic rock while exploring a volcanic crater in the Mare Imbrium, which we see as the man in the Moon's right eye. Despite such advances in lunar knowledge, China's space program began by repeating feats accomplished by its American and Soviet counterparts decades ago. However, the Chang'e 4 mission's soft landing on the far side of the Moon is a first in space exploration history. Chang'e 4, which was launched on December 2018, arrived in lunar orbit 5 days later and began lowering itself toward the Moon. Following a successful landing, it will investigate the von Karman crater within the vast South Pole Aitken Basin. The basin itself is the Moon's largest known impact crater and one of the largest in the solar system. The distance between its depths and the highest surrounding peaks is approximately 15 kilometers or 8 miles, which is near twice the height of Mount Everest. Details on Chang'e 4's landing were scarce in the run-up to the historic touchdown. CNSA is notoriously secretive. The most recent update simply stated that the spacecraft has entered its final pre-landing orbit. But why did it take so long for the first mission to land on the Moon's dark side? It is because communication with Earth is difficult to maintain during a far-side landing because the Moon itself blocks radio contact. The Apollo astronauts were completely cut off from the rest of humanity when they orbited the Moon's far side. The Chang'e 4 mission avoided this issue by using a relay satellite. CNSA launched the relay satellite into orbit around L2, a neutral point beyond the Moon where the gravity of Earth and the Moon cancel out an object's centripetal force, effectively allowing it to park in place. The relay satellite will bridge the gap between mission control and the Chang'e 4 lander because it always has good sight lines to both Earth and the lunar far side. Adding a relay, however, requires radio signals to travel a greater distance, increasing the round-trip communications delay. This means that any far-side lander or rover, including Chang'e 4, must be able to choose a landing site while also avoiding hazards completely on its own. CNSA chose the von Karman crater in the Moon's South Pole Aitken Basin, a low-lying feature 1,500 miles across that covers nearly a quarter of the Moon's surface. The basin is thought to have formed as a result of a massive impact, so studying it should reveal information about the Moon's crust and interior. It can also reveal how metals foreign to the Moon got there. Let us know what you think about missions to the Moon in the comments.